Students, today we are going to study about the second part of surface chemistry, that is catalysis, which is the second subtopic. In the first topic subtopic, adsorption, in the last class we have completed a very important difference, physical adsorption and chemical adsorption, followed by adsorption isotherm. So adsorption isotherm, Freundlich adsorption isotherm, its mathematical equation and graphical representation. Along with this one, we have studied adsorption in solution phase. So for that also we have applied the adsorption isotherm, and finally we have completed that subtopic with the applications of adsorption, which all I have covered in the last class. Now in the second subtopic known as catalysis, in this case first we'll go with the definition of catalyst. Catalyst, already you heard about this term, one which makes the reaction faster here, but what exactly definition, we'll go through it here. So you can see all the definitions here. Substance which alters the rate of a chemical reaction. Which alters means which changes the rate of the reaction, and themselves remain quantitatively unchanged here. So themselves remain quantitatively unchanged, that is known as, after the reaction, are known as catalyst. The next part here, if we go with the promoters here, catalytic promoters definition, I hope you have understood the catalyst definition, and the phenomena is known as catalysis here. Promoter means those substance which increases the activity of a catalyst are called as promoter here. One of the example means, the term itself says promoter means which promotes the efficiency of catalyst, which helps the catalyst to makes the reaction faster, still faster here. That is known as promoter. It promotes the efficiency of the catalyst here. The substances which increases the activity of catalyst are called promoters. Example, molybdenum promoter, whereas iron is a catalyst in Haber's process manufacture of ammonia. So iron is used as a catalyst here, and this promoter is molybdenum. Molybdenum acts as a promoter. It increases the activity of a catalyst. How it increases the activity of catalyst, later on we are going to study about that one here. So as there is a substance which can increase the activity, there must be another substance which may decrease the activity of a catalyst here, which may decrease the activity of a catalyst. Such a substance is known as catalytic poisons or catalytic inhibitors. We are also known as catalytic inhibitors. The substance which decreases the activity of a catalyst. So how it decreases the activity of a catalyst? By blocking the active centers of the catalyst. By blocking the active centers, they decrease the efficiency of the catalyst. Such process is called as inhibition, catalytic inhibition, or the substance is called as catalytic inhibitor here. The next part here, so the three terms we have studied: catalyst, promoters, catalytic poison or inhibitors. The next one is type of catalysis. In case of type of catalysis, there are two types of catalysis: homogeneous and heterogeneous. So as you know these terms, homogeneous mixture, in the first year you have studied. Similarly, homogeneous catalysis. In homogeneous catalysis, both reactant and catalyst are in a same physical state. Both reactants and catalyst are in the same physical state. Is given the example, homogeneous catalysis: oxidation of sulfur dioxide into sulfur trioxide in presence of nitric oxide. So there you can see this one here, where sulfur dioxide is in gaseous state, oxygen is also in gaseous state, as well as nitric oxide, which is used as a catalyst. That nitric oxide is also in gaseous state. All the three means two reactant and one catalyst, all are in the gaseous state, all are in the same physical state, all are in same phase. That such type of catalyst is called as homogeneous catalyst, and the phenomena is called as homogeneous catalysis. Usually they will ask you the example for the examination. Give an example for homogeneous and heterogeneous catalysis. Similarly, The other examples you can see or look over that. Second example, hydrolysis of methyl acetate is acid hydrolyzed or acid catalyzed. Hydrolysis of methyl acetate also we can say. H plus ions are furnished by hydrochloric acid. So methyl acetate CH3COOCH3 on treatment with water on hydrolysis, it gives acetic acid CH3COH and methyl alcohol here. Okay, in this one we are using the catalyst here. The catalyst and all the reactants are in a same physical state. Which is the catalyst here? H plus ion, acid catalyzed. Hydrolysis means treatment of water. Methyl acetate is in liquid state. Water is also in liquid state, and even in acid catalyzed means which is furnished by HCl solution. HCl solution is also in liquid state. Therefore all the three are in liquid state, hence it is known as homogeneous catalysis. One more example is also there, hydrolysis of sugar, acid catalyzed hydrolysis of sugar. So cane sugar we can write it as C12H22O11, which is known as sucrose. C12H22O11 on treatment with water in the presence of acid H2SO4. So where it converts into glucose and fructose. Here also all the three sucrose, water and catalyst all are in a same physical state, hence it is known as homogeneous catalysis. Next part here, heterogeneous catalysis. When catalyst and the reactants are in different phases or are in different physical state, the catalytic process is said to be as heterogeneous catalysis here. Okay, both the catalyst and reactant are in different phase. Okay, examples is given there. Oxidation of sulfur dioxide into sulfur trioxide in the presence of platinum. In the presence of platinum, there earlier same oxidation of sulfur dioxide to sulfur trioxide in presence of nitric oxide is an example of homogeneous. But if I use platinum, it becomes an heterogeneous catalysis because platinum is in solid state and sulfur dioxide is in gaseous state. Both are in different physical state, hence it will be an heterogeneous catalysis. Similarly, you can go for manufacture of ammonia where iron is used as a catalyst. Iron acts as a catalyst which is in solid state, whereas nitrogen and hydrogen both are in particularly gaseous state here. Okay, you can see over that point here. Next one here, the manufacture of ammonia into nitric, this third example you can see out there, where it is also an example of heterogeneous catalysis. What is the third example? Oxidation of ammonia into nitric oxide. Oxidation of ammonia into nitric oxide in the presence of platinum gauze, Ostwald's method, where manufacture of nitric acid it is. So where ammonia and oxygen are in both are in gaseous state, whereas platinum is in solid state. Hydrogenation of vegetable oil into vanaspati or dalda. Hydrogenation of vegetable oil using in presence of nickel catalyst here. Nickel is in solid state and hydrogen is a gaseous state, therefore it is an heterogeneous catalysis here. Now the next part we are going to study a mechanism of heterogeneous catalysis. So very important, this they may ask you to explain the mechanism of catalysis. Two theories are proposed. Two theories are there. One is adsorption theory, another one is intermediate compound formation theory. So this adsorption theory we are going to study it here, where intermediate compound formation theory we are going to study it in chemical kinetics. There also you are going to study about catalysis. There you are going to study about intermediate complex formation theory. In adsorption means in surface chemistry, that's also in catalysis we are studying adsorption theory to understand the mechanism of catalysis, how it changes the rate of the reaction, how it increases or decreases the rate of the reaction can be understood with the help of this adsorption theory here. Adsorption theory of heterogeneous catalysis. You can see there are 5 steps here. So diffusion of reactant to the surface of the catalyst. So this one you can understand with the below given diagram, where A plus B are reacting molecules, and catalyst surface is also given there, and from that one both A and B reactant are so diffused here. Diffusion of reactant to the surface of the catalyst, adsorption of reactant molecule on the surface of the catalyst. The first one is, can see here, particularly, okay, you can see that the first step, diffusion of reactant A plus B reactant, where I am marking it here. You can see that one here, the above point. So reactant and this one here, catalyst are diffused here. Further, if you go with this point here, in this case both adsorption of reactant molecule, reacting molecule, adsorption of reacting molecule, you can see over that. Then afterwards the third step, that is occurrence of a chemical reaction on the catalytic surface. So first one is diffusion, second one, diffuse means they get come nearer to the catalytic surface, reactant molecule. Second step, adsorption. Third step, they react here to form an intermediate. Okay, so adsorption, occurrence of a chemical reaction on a catalyst surface through formation of intermediate. Fourth step is desorption of reaction products from a catalytic surface. So desorption of reaction product, whatever the product is formed, it is desorbed, means it is removed from the surface of the catalyst. And last one, diffusion of reaction product away from the catalyst surface. Okay, diffusion of reaction product away from the catalyst surface, means removal from the surface of the catalyst here. So this way we can study adsorption theory of heterogeneous catalysis. This diagram is very important, and all the 5 steps you should write it here. Very simple way you can understand. So how this mechanism occur, how the surface of the means how the catalyst will increase the rate of the reaction. So what happens here, so if A and B are reactant, when they get adsorbed, before getting adsorbed they get diffused first, and then they get adsorbed. When they get adsorbed, A and B reactant molecule on the solid surface, when they get adsorbed, heat is liberated. Heat is liberated means temperature increases, and when temperature increases, reaction becomes very fast. This all happens on the surface of the catalyst, that is after adsorption. So heat is liberated, as a result temperature increases on the surface, both the reactant readily combine to form a product. As the product is formed, it get diffused from the surface of the catalyst. So these all are the 5 steps you should make along with the diagram. Very important part for the adsorption theory of heterogeneous catalysis. The next one is important features of solid catalyst. If the catalyst is in solid state, there are some important features here. Activity of a catalyst and selectivity of a catalyst here. Activity of a catalyst means the ability of catalyst to increase the rate of a chemical reaction is called activity. It is the ability of a catalyst to increase the rate of a chemical reaction. Okay, that is called its activity of a catalyst. What is the role of catalyst? Is its ability to increase the rate of the reaction. What is selectivity of a catalyst? It is the ability of a catalyst to direct direct a reaction to yield a particular product. Okay, so to direct a reaction to yield a particular product here. So that is very important here, selectivity. So if I use different catalyst, I'll get different product here. It is directing the reaction to yield a particular product here, that is called selectivity. So therefore these are the 2 important characteristic features of solid catalyst: activity of a catalyst, selectivity of a catalyst here. The example they have given here, carbon monoxide and hydrogen. What is the meaning of selectivity? Selectivity here, carbon monoxide and hydrogen, if they combine here in presence of nickel catalyst, methane is obtained along with the formation of water. So if the same carbon monoxide and hydrogen reacts with copper bar zinc chromate in that particular catalyst here, then it gives methyl alcohol. So this is called selectivity. Selectivity of a catalyst means ability of a catalyst to direct a reaction to yield a particular product. Here nickel directs a reaction to yield methane, whereas in the second one, copper in presence of zinc chromate, it directs the reaction, or it directs the reactant to form methyl alcohol. Okay, so these are the some activity and selectivity. The next one is shape selectivity, shape selective catalysis by zeolites here. So zeolites are the shape selective catalysis here. So what are exactly zeolites? Zeolites are nothing but shape selective catalysis here. Okay, about this one we'll study it in the next class. Okay student, go for today's we have studied the three definition: catalyst, promoters and inhibitors. Then afterwards followed by homogeneous and heterogeneous catalysis definition along with the examples. Then mechanism of heterogeneous catalysis also we have completed, which occurs in 5 step along with the diagram. It is very important. Okay, now in the next class two another catalysis are there: shape selective catalysis and enzyme catalysis, that I'll cover it in the next video here. Okay, thank you students, take care.